At least just try. Is detailing of a cantilever slab, given that the slab is like this. Now in the question, the design parameters is given as follows. A wide 12-foot span placed at 150 millimeters center to center. 2. Wide 12 mm span bracket distribution placed at 175 millimeter per center to center. Third one, wide 12 continuous edge top placed at 150 millimeter center to center. The fourth one, wide 12 continuous edge distribution placed at 175 millimeter center to center. And the fifth one is assume the slab is monistically connected to the supporting beams. Make other reasonable assumptions where necessary. Now how we are going to tackle this particular problem is, now when dealing with a slab, we have to know which one is our B1 and our B2. Our B1 is our main distribution bars, while our B2 is our B2 is our B1 is our main bars, while our B2 is our distribution bars. So when working in distribution bars, is how is arranged is this. Is placed at the shorter span, like this. Or yes, let's work with this part. Between here and here, which one is bigger? This 3,000. So this is our B1 will be placed at. I'm stopping here because this span and this span are different. That means it will have a different this thing. Oh wait, this span is longer than this. So normally it will be the same main bar. Main bar that will be running through this slab. So it will be like this. And I'm putting a top distribution, a hook around this axis here. Why? Why are we putting the hook? Because normally when you're placing a hook, there's a bending. Like, see how the thing is for a normal slab. Yeah? Why did I place it straight? Because if you look at this slab here, the main bar will be like, the main bar will be running through here. You see that? Still running like this. Because it's on the shorter span. Yes. Wire is on the longer span. The length of pushing. Me here. This other one. Okay, this span. Okay, mean the cantilever. Pushing. Okay, the rod. Okay, mean my okay. Okay, the return. I'll work on that. We are coming to that. I forgot to add. This span will be 1, 2. So this is the strong bar. How we are going to calculate it is, since it's spanning on the shorter span, like it's parallel to the shorter span, we're going to do it like this. This distance is 4,800. We're going to do 4,800 minus 225 because half of this is 112.5. Half of this is 112.5. So by solving for this B1 here, it will be like this. 4,000. Okay, let me write down the formula for you. The span over the spacing plus 1. That will give you our main distribution bar that is running across this slab. Now the span given was 4,800 because it's running vertically, because this reinforcement is running top to down. Also minus wall size. Add that. Minus our wall size. Plus 1. So since this reinforcement is spanning from here, from this top to here, is 4,800, that will be our given span. which is 4,800, divided by the spacing. The spacing you're working on is mid-span. Mid-span means is a bottom distribution bar, while continuous edge means is to a top reinforcement that is running through the slab. So mid-span means, okay, they gave us a mid-span place at 150. That would be our main. This will be our main this thing. So our spacing is giving us 150 mm. So we'll just put 150 minus our wall size, given that here is 112.5, while this down is 112.5. If you add them together to give it 225, we'll minus 225, then plus 1. What will be our answer? Answer. 31.5. 30.5. How? Do this 4,800 minus 225 divided by 150 plus 1. Uh, yeah? 31, 31.5. That is approximately, okay. So you're getting 31.5, which is approximately 32 bars. Bars. So under here, say I'm going to place it. I'm going to draw a indicator. And always make sure that this line is always a thin line when you're drawing this, because normally for normal reinforcement, make here to be thick, while here to be a little bit thin. So I'll just put here, I'll put my donut here. I'll draw another this thing again. I'll put my donut here and I'll indicate 32 y12 Bamak 1. That is the main bar we are starting with. 150 center to center B1. I don't know if you guys can see it. That will be this thing, our first division. Then put an indicator. And I made a mistake here. This is a cantilever. So there isn't supposed to be a hook around this place, because here is a continuous edge. But if it's discontinuous at this edge, there's supposed to be a hook. So this is our first one now. First, now we'll solve for this thing, our distribution bars, which is spanning from here to here. So when looking for distribution bars, it will be like this. Hmm? Yes, I'm going for one. Distribution bar is spanning from the longest span. This is the longest span here. So we are going to, that is parallel to the longest span. So we are going to do it from this span to here. What will be our distribution bar? Yeah, or we can still work with this entire length like that, this entire length here. So what we are going to work on is, when solving for distribution bar, is 4275 minus 225 divided by our distribution bar is giving us 175. That means our spacing is 175 plus 1 is equals to what? Examine or bright. 24 point 24.3 point 3 point 1 24.1, which is approximately 24 bars. I'll leave that aside because number one, this is a description bar which it will be spanning from here to here. You can draw another line again, another thing, but it won't mix. I'll just make sure that it's spanning from this side to this side, from here to here. So what we're going to work on is we'll work on this other one, this other span, which is 3,000. So 3,000 minus 225 divided by our 175 plus 1. What are we getting? Hmm? 16.5. Okay, approximately 17 bars. Now, why I'm doing it like this because there isn't enough space for us to draw these reinforcements here. So I just want to place it one time at a go. So I'll draw a line, a little line, an indicator spanning from here to here, then from here to here. I'll add these two values together, which is this 17 plus 24, which we are getting as 41, Abby? 41 bars. 41 bars. So I'll indicate 41 Y12 bar mark 2 at 175 center to center B2. So these are span from here to here. You know why I got this value? Because this 20, always remember you have to put a donut here and here, here and here, because we are minusing the two wall sides together. Head how? So I've both gotten our main bar and our description bars for this cantilever. Now what we're going to work on is our T1 and our T2, which are top bars. How you're going to do it is, okay, this is only one here. I will indicate. Normally, when you're drawing for your top bars, always make sure it's dashed lines. And I'm putting a dashed line in between this hook here. Now, Bronson, he asked me a question. Say, what is the span of this hook? Is 0.15 times the span, which is this 3,000. Yes, when you're getting the hook. I want to show you guys something. This is the slab we're working on. If you want to cut a section towards this slab like that, and see the support that's holding this slab together. This 1, 2, 3, which is like it's giving like this. So it will be like this. A but here is a cantilever to end here. So the reinforcement you are putting on is here, these top bars, here, 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 here. Those are the ones that need critical support. So Brownson asks, wow, what is the length here? What you are getting for this top distribution bars that we actually need is 0.15 times the span. While here, this middle part, this middle span is 0.3 times our span. The same thing applies to this. Hmm? Which one? The numbering. What happened to the numbering? 175 center to center B2. I not seeing the B2. Yes, this part is B1 because it's spanning it's parallel to the shorter span. This is shorter span, yeah, like these two, the shorter span. It's parallel to here, so we'll just indicate here as um, yes, this one is B1 because this one is spanning on the shorter span. This here is B1. This one is parallel to the longer span. So here is B2. You understand? Mm. It's different from the cantilever. So any question? Yeah? Which values? You mean for this different span, 3,000 and this? I thought we work on 3,000 first. We did 3,000 divided by the span. Why we work on 4,275 divided by the span plus 1. We add the two values together. You remember we minus it by the wall size, which is 222.5. That's how we got the 41. Mm. I don't know if somebody wrote that. You write it down. He's wondering how we got the 41 Y12. So what we're working on is our T1. Which one? T2. Okay, I didn't put it where. You do not. They're supposed to be donuts. So we are clear on this now, B1 and B2. Everyone is clear on B1 and B2. So we are working on T1 and T2. Now, given that the value, they give us a Y12 continuous S, which is top, placed at 150 meter. This will be our T1. Why your distribution to be our T2, like this. So what we're working on is our T1, our top distribution bar, our top main bar, which we are placing it here. This will be our rod. Why is given as dashed line? Because normally for top bars, top reinforcement bar is supposed to be dashed lines to indicate that it's actually on the top. So I'm placing it at this span from here to here. I'll draw an indicator and I'll put my donut here to signify that this my reinforcement is spanning from here to here, this distance. And this distance is 0.15. 0.15 times the span, then times the span and length of it. So if we do it like this, 0.15 times our span giving us 3,000 divided by our space in the top description block. Okay, 150. minus our wall size again. Yes, minus our wall size 225. What are we getting? Right. What are we getting? Do this value. Yes, minus 225. I'm sorry, 112.5. Half, like half of this wall size. Sorry. Yes, 112.5 divided by the spacing plus 1. What are we getting? How? You do 0.15 times 3000 minus 112.5. 112 divided by 150 plus 1. Huh? 3, 4. That is 4. As how? 0.25. There's approximately 3 bars now. 3 bars needed. What? So I'm hearing 3.25. I'm hearing 384. 3.25. Therefore, I'll put an indicator here, which is telling me that this my reinforcement is spanning from 3Y12 bar mark 03 at this top reinforcement 150. 150 center to center T1. So you guys understand? Want to, because you are minusing this half and this wall size here. I see it. Hmm? Yes. 0 point, because see our first bar mark 0 1. See our this thing, our second bar mark 0 2. This is our third one 0 3. You understand? Is that we clear? Now we are working on this one. First of all, we are working on all the T's, T1 inside this cantilever slab. So I'll draw here. Here I'll put a span from here to here and a donut. For me to get this reinforcement here, the T1 acting on this thing here, it will be 0.15 times our span, which is 4,800, minus our wall size 112.5 divided by 150 plus 1. That will give us our reinforcement for this part here. I'll do 0.15 times 4,800 minus 112.5. 5.05, which is approximately 5 bars. So I'll put here as 5Y12 bar mark 04 at 150 millimeter center to center T1, which is giving us this. Then we'll work on this one is still the same thing now because the span is still the same 4,800. So yeah, just draw a span indicator. I'll put my donut here. So I give now still that 5 bar mark 0.5 150 mm center to center T1. I don't know if you guys can see it. Then what else is now working on? Okay. No. Yes, for us to get our span. But okay, our last one is this thing, our distribution T2, which is 175. Okay, people won't use. Okay. This down part. Okay, let me be writing down the first bar mark there. Okay. Our first bar mark we got was 32 white 12. Just like that now. T1. Yeah. Only one side. Mhm. Yes, because this part, this part is a continuous edge like that. Like say this part is discontinuous. Like say there's no a cantilever here. I'll just do a hook and indicate that I'm doing another reinforcement. Just like that. So we are done with T1 in this question. Or anything I have to consign T1, we are done with it. So we'll just do T2, then we'll go away. Or we are not done with T1 per se. See there, I told you that, but shall let me just write down the bar marks first. So you guys won't be confused. Three white, three white wolf. Okay. Okay, guys, I don't know whether you guys are seeing this thing. I see this part here. Now, how we are going to get this particular value is this indicator. This is a different span, 0.3000 millimeter. And what we are going to work on is this 0.3, because these are the middle part now. This is 0.3 times our span. I mean, sorry, 0.3 times our span, which is 3000. Yeah, I'm doing this one, this other value again. I told you that when you're there are three supports. I mean, sorry, three supports given this particular distance like that. One, two, three. Why here is 0.15? Here is 0.3. This is the middle support here. So I'm trying to draw the top reinforcement. My T1 acting on this part here. So I'll just put an indicator from. Well, this is confusing, but from here to here. I'll put my bar mark. That is telling me that this span, like this reinforcement, this rod is spanning from here to here. That is this 0.3 times 3000 plus 1. I'll give my reinforcement here. Hmm? Sorry, oh, that are the listen. What's in the call that thing again? No, no, these ones are grid lines. No, it's just to indicate the span of this. It's spanning from here to here. That is what the grid line means. That guys So for us to get this particular this thing like that, this reinforcement spanning from here to here, which is 0.3 times our span divided by our spacing, which is 150 mm plus 1. Our span, which is given as 3000, divided by our spacing, 150 plus 1. What are we getting? Then we'll do for the other part again, this reinforcement spanning from here. This reinforcement is spanning from here to here. I draw two reinforcements. This part, which is spanning from here to here. Then another reinforcement here. What it means that this is my reinforcement too, and it's spanning from this here, this other one end, and here this other one end here, which is at 0.3. 0.3 times our span, which is 3000 plus 1. That will give me a number of reinforcements that is spanning from here to here. Understand? Then I'll do for here too. So what are we getting? 7 bars. The other one is what? Are you confused? You're confused. From here. See, 10 bars. Right. Why I'm hosting this tutorial is for you to understand. So at least just they ask questions. Ask me questions. Where are you confused? Which part? Talk now. Yeah? I'm not hearing. So, 0.15. Like if there's a hook, there's an indicator that this is a hook here. That is 0.15 times the span given. Middle 0.3. Just like that. Any question? Any question? Brian, any question? You know, ask me. Talk to me during exam hall. Yeah, yeah. What support? Okay, this is the first support. One, two, three, four. It will be like this. This will be a hook here. Hook will be placed at the end because uh, 0.15, wire 0.15, wire is 0.3, 0.3. Hmm? Hmm. Starting from here. Right, come here, come here. Yes, this panel is super span. Question. Yes. Write down the solution. Yes. 41 bar. 21. That this is a reinforcement here, and this top one is spanning from here to here. This is what it means. So it's spanning from here to here. This ring. So is that 0.15 times 3,000. That's why it's giving us a small value, which you got as what is 7y. So 7y is spanning across this hook. That's what it means. That's what. No, no, no. This one does not have a hook because here's a cantilever. Here's a cantilever. Eh? No, no. I see it now. I've changed it. It's supposed to be normally top member. See it here. This is my reinforcement. This down here, and this another reinforcement. It's spanning from here to here, and this place to here. That is 0.3 because these are the middle part of the distance. Mm, 0.3. 0.3 times the span, which is 3,000 plus 1. The draw indicator. This is how it will be. 0.3. I don't know. Is anybody confused? Is anybody confused? Are you drawing it? We'll draw for that board. Where is that? We'll finish T2. After we're done with T2, we don't finish. We enter cantilever. This cantilever, whenever design cantilever fail, there's only two things we just do. Then, yes, a question. Just do this in time. Save. Press Ctrl S now. Save the file. 0.15 is this hook. Remember that this is how the thing will be like. Okay, this is how the slab is. This is the hook, which is this. So the 0.15 is this reinforcement bar that's spanning from here to here. That's 0.15. Yeah, it's a constant given the BS code. So 0.15 times our span, which was 3,000, divided by the spacing, 150 plus 1. That's how to go the reinforcement. Yeah. Just leave it. Just leave it. Just to make, let's indicate that okay, even though you minus it or you don't minus it, it will still give you a value that's close to this. Which one? Which one? Uh, my hook. Put a hook, yeah. You can extend it to the cantilever, but normally, just to confuse, I can still extend it to the cantilever. So are we done? Yeah? Which one? No, the 0.15 is from this hook. The hook that is bending. Mm. The 1.5 is coming from this middle support here. This middle, yeah, the exam. I don't know if you reach up to 3 hours. No, no, money paper. Let me see. But you're getting 6 and 7. They are still close now. I told you. Mm, it's still close. Still close. Still close. If you don't want to minus the wall like that, you can just minus the like. They will give us 4 questions. Answer either 3 or 2. I don't know whether 2, 4, 4. Elvis, are you lost? Are you lost? Are you lost? Yeah? Yeah, as you know, get system, you can't plot it. But somewhere they draw this thing. Let me see. No, we'll go into slab first. See how this slab is complicated. See all this reinforcement you are putting in. At least make you guys understand how to do your B1, B2, T1, and T2. Then after that, we enter staircase. After staircase, we enter this thing. This thing. Hmm? 150. It's part of the question. Oh, T1, 150. So here, stop safe. Bar mark 0, yeah, the 7D. So we have work on this. We work on this part here, this reinforcement. So I'll do a this thing. I'm going to draw another reinforcement bar here. Yes. So I'll draw my reinforcement, which is still that the same thing. This reinforcement is spanning from here to here, which is that 0.3. 0.3 times our 4275. You understand? Which is giving us 10 y12 bar mark 08 at 150 mm center to center T1. Okay? This support here. This support. So we are work on T1. No, 0.3. 0.3 because this is not a this a continuous edge. This is not a discontinuous edge. Like say this is a discontinuous edge, we'll put a hook. And that hook is signified as 0.15. Now we have already solved for T1. Now we are working on T2. T2 is like this. I see this reinforcement that we did here that is spanning from here to here and here to here. Now this reinforcement is spanning from this side to this side. So I'll indicate, I'll draw a reinforcement here. This is my hook. I mean, this is my donut. I'm placing it here. Now I'll put a span from here to here. That will be 4,800 divided by our T2. T2. See our T2 here. I see it. This one. I see it. Okay. That's it. T2. So I'll just do that 4,800. 4,800 divided by our T2 is giving us 175. 48 divided by 175 minus our wall size 225 plus 1. What are we getting? Calculate. 27. 27 bars. Or indicate, yeah. 10y12 08 150 mm center to center T1. Y here is 27, y12 09 175 center to center T2. So we are done. Now we're entering the cantilever side. Now see how the cantilever is. Can I borrow your book first? This is how the thing is. A normal cantilever has a fixed end. Yeah, and when there's a force acting on it, it will bend, it will have a hugging moment, which is this top. So we are going to place a reinforcement at the top bar to prevent it from hugging. Normally, for normal slab, normal supported cantilever like that, if you place a force at the middle part, it will deflect. But this one, cantilever is hugging at the top. Yeah, so our main concern is placing a reinforcement at the top here. So these are the reinforcements supposed to be like. And you guys should note that when you're placing your this thing here, your reinforcement, know that this cantilever edge is spanning from 1.5 L. 1.5 L is 1.5 times the span given. That is this thing. That will be our span given here. When you're placing your reinforcement like that, after this, your beam passing, know that is 1.5 times our L, which is our span, which is this. Then this will indicate here reinforcement for this will be our T1. For this cantilever will be this 4,800 then divided by T1 150 is what? Hmm? Yes. Now at the ending, see how the reinforcement is. You know that this is a cantilever. Let me draw for board. This is a cantilever. This is a fixed support. And see the force that is acting on it, making it to deflect. And we are putting a reinforcement here. So our primary concern is this top reinforcement for making it to hug. That's why I'm putting this reinforcement here at this top. No, when we are doing section, when we are cutting the section, it's not going to read. Which one? I'm talking about the cantilever. Your laptop. You go draw am now. You draw am. I'm coming when I finish. Mm. That is this 4,800. You're not minusing by the wall side because there's no wall side given. Divided by T1, 150 plus 1. What are we getting? Bridget, they draw this thing now. Bridget, they draw this thing now. 33. Yeah? 33 waiting. 33. So our bar mark is 10. This is our 10th one. So 33 Y12 bar mark 10. 150 mm center to center T1. Our T2 is just the opposite. We just draw a straight line here, which is spanning from here to here, which is this 12,000. So I'll just do 1,200 divided by the spacing T2 175 plus 1. What are we getting? T2. And we are done with this question. We are done detailing this thing. Okay, 1.5, which is this reinforcement. Yeah, we can also put a reinforcement. Yeah, that is spanning from here to here, which is our T2, but it's no need now since we are ready to solve for it. Oh, what do we get here? That 1.5 L. What was the answer? Uh, no, 427. Hmm? Which one? Which line? 31. Is it 33? That 33. Let's continue. edge. You're not removing 225. Mm. You know, just it's still the same thing, somewhere close to it. At least we are you're not removing any 225. Uh, grid line to the grid line. So there's one thing like that Bridget just mentioned. This 1.5 L. So we're going to draw a reinforcement. This reinforcement here, this top bar is spanning from this part to here. That is that 1.5 L. So our 1.5 L, which is giving us 1.5 times 4275, is giving us what? 6,000 waiting. Calm down now. Bridget, calm down. 6,000 waiting. 413. Yeah, you divide it by the spacing because that part we will be working on is our T1 again. That is T1. This reinforcement. No, this reinforcement. No, it's T1. Have you seen this part here? What this part you are doing is T1. From here to our T1 is what? 150. 150. Okay. Divided by 150 plus 1. Wait, 43.8. 43.8. What do you get here from this span to this span? 43. We got 41. How is this thing 43? No, do you 1.5 times the L? We did like this. 42 this thing divided by 150 plus 1. Continue. Okay. 1 point, yeah. Okay. The length of the cantilever. Sorry. Like one. Yes. Uh, 13. Yeah, for this reinforcement, if you draw an indicator line here, which is spanning from here to here, that is, what do you say again? What's the answer? 13. 13, Y12. Bar mark. What again? 12. No, 12. C11, yeah. This side. Bar mark 12. At 150 mm, center to center, T1. We are done. The cantilever side. Okay, 33 now. Alpha, who is getting issue in drawing this thing on their computer? Like all these reinforcements. You don't understand. From here to here, if you just try come in and those parts you don't understand, at least try indicate. From here to here, you don't understand. What that cantilever here? Give me your book first. Let me show you something. Okay, now look at this. Look at this slab now. This is the first support. This is second support. This is third support. That is one, two, three. These are the supports. If I draw it a straight line, this cantilever does not have any support. Now when you want to do this thing, like you start your this thing like that, this is how the thing will be like. There'll be a sagging moment at this down part, a hugging moment here, sagging moment, hugging moment. Then at this end point, you stop at zero. So the reinforcement you're working on is here, 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 here. You understand? So this cantilever, since there's no like we don't need any bottom reinforcement because there's no sagging at the cantilever. You're not using any bottom reinforcement. That is those B1 and B2. So it's what we're working on is T1 and T2. So is T1 is that this reinforcement you just put here, spanning from that one to understand. So our top reinforcement. So the first our first one is that span 4,800, which is spanning from here